just gonna record it. So then next time I don't have to like re-talk about this anymore. Okay. So okay, so it's a slideshow now, right? So this is the lab about line balancing, and here we are going to pretend that you guys are the owner of a manufacturing plant, and this plant is going to produce two types of the product, which are, this left side car, which is called a sedan car. The right side car here is the racing car. So we have two cars that we have to produce. You are the owner of the plant. Then, how are you going to produce that using the line balancing tool? But before that, we'll just go over with a little bit of the lecture. So here, at first, if you are going to do the lab in class, it's going to be, a simulation of an assembly line. But unfortunately, you guys could not do it at this stage. So hopefully you guys still get the essence of the knowledge as much as what I aim for you guys to get. Okay. We are not gonna do the timing and everything, but I believe you guys can just do it easily. Timing for me is not, the problem at all. So assume that assembly line or a product layout is a line that you have, certain workers working in each station, like station 1, 2, 3, and 4. And then you have different types of product. And those products are going to be produced in each station separately, one by one, continuously. So this is the thing that we want to do together. So let's imagine, for example, that if you have an assembly line that looks like that, you have 4 stations, station 1, station 2, station 3, and 4. Station 1 takes 5 minutes. Station 2 takes 25 minutes. Station 3 takes 15, and station 4 takes 10. What can you see are the problems of this assembly line? Can anyone help me answering this? Just try out. What are the problems? If you are the owner of this line, are you going to be happy about it? Happyไหมคะ?
No.
Why?
Some delay will happen along the process.
Where คะ?
Maybe session 2.
Yeah, station 2 is in like in IE term, we call station 2 is a bottleneck of the line because station 2 takes the longest time. So in here you can see a lot of problems, and let me just show you guys the problems here. Station 2, as mentioned earlier, is going to take the longest one. So station 3 and station 4, they're not working as much as you want them to work because they still have to wait for station 2. And that's a waste in the production, right? And in the same time, station 1, they have he or she has 2 options to do. The first one, if he's really, hardworking, so he's just going to keep working on his work. It takes only 5 minutes. So he's going to have a lot of, unfinished part laying down on the floor like that, a lot. And what I mean a lot is a lot. Or he can be lazy. He can work for 5 minutes and then, wait 20 minutes just playing around, talking to your friends and blah, blah, blah. And then come back for another 5 minutes of work and then just, be laying out. And that can be his option too. So this like, you can clearly say that this line is not balanced. So, these are the ways that you can identify in this production line. And I think you will also learn about, production ways in your work study class. I don't know if you've heard about it yet because your semester just started, But yeah, this is going to be something that you will learn in the work study class. This lab is going to be helping with the work study class and also the PPC one. PPC, which is the production planning and control in the next semester. So as mentioned earlier, you have the bottleneck, you have the waiting time, you have the underutilization. And the last thing is that you have a safety issue. I have seen a lot of PP who did the research. This is the senior topic. And, many of them have done a study about, many of the plants that they've been working with. They have like parts lying around on the ground, very like all over the place. And that's a common problem that you can see when you go and work in a typical factories. So this can also be another problem. And I think another problem that I can raise here is that, once you have unfinished products lying a lot in your factory, that means you have uh your money lying around there, getting nothing. So if one day, COVID-19 happen, or there's a flood in your factory, everything will be gone. And especially when your product has a shelf life, if the product has a certain age and you cannot wait until the next month to continue you doing your product, then that's certainly a waste of money. So be aware of this a lot. I think it's one of the main essence of IE, like do not have way too many work in process. The unfinished parts in the factory, you call them work in process. Okay. All right, so one thing that you can easily solve this problem is that you can just cut some of the work from the second worker to the first worker, and things will be more balanced out in this case. Of course, in our lab, it's not going to be this simple, but this is just one example. I'm just going to skip this one. But in order to do the line balancing procedure, the first thing is that you have to identify the task. Like, okay, so if you want to make like these pens, the baby pens, then you just have to know the steps to complete the task, right? To complete one pens. What are the steps? Like, okay, you have to cut out the cloth. That can be one task. The next task is to like kind of like sew the cloth together, sewing the piece together, adding the string and things like that. Those are called tasks. So in your real project, you have to identify your own tasks in the project. But in this lab, I already define the task for you. And then once you have the task, the next step is that you have to create what's called a precedence diagram. So in this case, a precedence diagram is like, you just have to know which task must be done before the next task can happen. So for example, if you are like the owner of the cell phone manufacturing plant, and so you just have to know that you have to add the battery first before you cover the back of the before you put the cover on a cell phone, right? So which task has to be done prior to the next one is called precedence diagram, which we are going to do also in this lab. And then you will time the task. In here, we're not going to time it. I'm just going to give you the time, and then we'll do the line balancing technique, okay? So in order to do the line balancing technique, first thing first, we have to decide how many people do we need in our assembly line. So in order to calculate that, you have to know the workload, like the overall workload, how many how many minutes of work do we have to finish, like to do everything? And that will show in an example. And then this is WL, the workload, divided by the total time. So in here, in this example, in the lecture, I assume that the total time is 60 minutes or 1 hour. And this is because typically, most of the companies, they measure the performance of the line in terms of unit per hour or UPH. So that's why, I put 60 minutes here. But in the actual lab, we're not going to do, producing things for 60 minutes. That's too long for you guys. You guys are not the real workers, right? So, but in any of the project, easy one is just 60 minutes. You can do it in days or in weeks if your task takes like longer than the normal time. For example, if you have to like make a house or make a truck or things like that, that is like taking a long time for each task, then your T can be, days or weeks or even months. For E, the capital letter E here, this is the efficiency rate. Typically, you have to allow your worker to kind of rest, go to the toilets, just chatting around, relaxing a little bit. So you cannot expect your worker to work 100% of the time. So in this case, E can vary. The maximum percentage that you can require your worker to work for you is 96%. This is by law. So in this example, I think I used 96%. So let's see, for example, in here, this is a mock-up, factory. In this factory, you have to produce two products, product A and product B, okay? So in 60 minutes, the owner of this factory said that he wants, 4 pieces of A and 6 pieces of B. So in every 60 minutes, you have to have 4A and 6B, for the owner. You know that the time, you know that the time to produce each A is 27% and the time to produce the B is 25%. So in here, the overall workload to produce 4A and 6Bs are, 4 times 27 plus 6 times 25, and that's 258. So that's the overall workload. And in order to calculate for the number of workers, that's going to be, 258, which is the workload, divided by T. Remember the T. T is 60 minutes here. And E is the efficiency rate that you allow the worker to relax a little. So in this case, you calculated the number of worker to be 4.48 and you round up to be 5 because, number of worker has to be an integer. So now in here, you know that, okay, so in our factory, we need 5 stations in order to finish, 4 A's and 6 B's in 60 minutes. So this is the first step in the line balancing procedure. And then in the next stage, as mentioned earlier, you have to know the precedence diagram of the product. So since you have product A and product B, information here are as follows. So now you have more information about the task or element. You have to complete 8 tasks, like 1, 2, 3, 4, 5, 6, 7, 8. This column here, the time for product A, and this column here is the time for product B for each task. In total, you still have to do 27 minutes for A and 25 minutes for B anyway, but you have more information about the time in each task, and that's also needed in order to do the line balancing. This predecessor column here, this is very important for you to do the precedence diagram. So in this table, for product A, it said that element 1 doesn't have any predecessor, so element 1 can start off without waiting for any job to be done. But for element 2, 3, and 4, for example, these 3 elements have to wait for 1 to finish, and then 2, 3, and 4 can start, or even can start in the same, station, which we'll see, for example, in just a minute. So for this predecessor information for product A, you can write down a precedence diagram in the next slide like that. So let me just go over. So for example, product A, as mentioned earlier, one can start without waiting for anyone. So you can just start off with number one in circle. This is called a node. So you can start off with node number one. And then, you know that 2, 3, and 4 is waiting for 1. So it's going to be 2, 3, and 4 after number 1. So this is, the precedence diagram here. And then next is element number 5 has to wait for element number 2. So, after 2, you have a 5 here. And same here, element number 6 has to wait until 3 is finished. So 6 is waiting for 3 here. And then finally, 8 is waiting for 5 and 6. So you can go, 8 here, waiting for 5 and 6 to finish. And when you're done for product A, since you have 2 end nodes here, you're just going to add like a dotted lines and then say, you have finished creating your precedence diagram. And you also do the same thing for product B, like, starting off with a 1, 2, 3, and 4 is waiting for the number 1, 6 is waiting for 3, 7 is waiting for 4, and 8 is waiting for 7. And again, since you have 3 end nodes, you're just going to do the dotted line and say that it's finished. You can, superimpose these two products together because they are in the same factory. And this is the overall diagram for the two products. So in here, it's saying that, element number 1 is going to be required for both product A and B. But unlike element number 5, number 5 is only required for product A, or number 7 is required for product B. So this is the precedence diagram, which is the next step that you have to do in line balancing stage. And finally, this is just a a practice for you. So this is not the same example as what we said earlier, but it's just the practice so we can practice here. You have job element here, A, B, C, D, E, F, G, H, and you have information about the predecessors here. So here you can see that, task A and task C has no predecessors. So A and C can start it off without waiting for anyone. But here task B is waiting for A. So B is going to wait for A here. So B comes after A. And D is waiting for A and C. So once you have A and C, you can point the arrows both to D. Okay. And then G is waiting for B. Let me just go. Yeah. G is waiting for B. So G has a predecessor as a B. So you have this picture here that G is waiting for B. Again, E is waiting for D. So just keep going. E after D, F after E, and H is waiting for both G and F. So from here, you can see that H is waiting for both, F and G. By the way, if you have any questions, feel free to pause me at any time, okay? Otherwise, I'm just going to keep going. So this is just kind of like a practice. Let's just, erase things about this example now, and then we'll go back to the previous example that we've done. So first, we know that we need 5 stations. We know the precedence diagram of the two products here. And finally, we just have to calculate the time in order to do the line balancing stage. In here, as mentioned earlier, you need 4 pieces of A and 6 pieces of B. For example, for element number 1 here, A takes 3 minutes. If you need 4 pieces of A, then in total, to do task number 1, it needs 12 minutes. Same here for task number 1, B takes 3 minutes, but you need 6 pieces of B, then 6 times 3 is 18 minutes for task number 1 for 6 pieces of B. And just calculate, the time for each task for both 4 pieces of A and 6 pieces of B. And once you have all the time for the task, then you just add these two up. to find the time for 4A and 6B. So 30 minutes is to completing task number 1 for 4A and 6B, for example. 40 minutes is for, 4A and 6B for task number 2, blah, blah, blah. So if you add these up, the total workload is still going to be 258 as you use to calculate the number of stations. But here you have more information about the detailed time for each task element. Okay, so this is going to be the information that you will use in order to do the line balancing stage. Let me just the level here, level 1, level 2, level 3, level 4. This is actually things like that. So if I go back to this picture here, the level are actually like, this is level 1, this is level 2, and this is level 3, and this is the last level, level 4. Oops, this is 6, right? Sorry, let me just do it here. This one is not needed. So levels are not that important if you just want to do the line balancing, but they're important if you use the technique that we use here in the lab. But let me just go over. Okay, so next, these are just the levels. You're not really important that much. We'll see in just a minute. The more important things are the time and the precedence diagram. In order to do the line balancing, first you have to create this chart here. And the technique that we are going to use in this lecture is called Q-bridge and Wester's technique. So let's just get started. Here the time limit is 57.6, and 57.6 means that you have 60 minutes for the total time, multiplied by the efficiency rate, which is 96%. So this is the maximum time that you can place your jobs into the workstation. So let's just see, for example, this chart here is called Yamasumi chart, which is from Japanese, I think. Okay, so let's just get started. The information that we can just gonna use are, the time here in this column and the precedence diagram, precedence diagram here. So in order to select the task to be in your first station, you just have to select from the task in anything in level 1, like the first task that you can start without waiting for anyone. So from the precedence diagram, that task is only task number 1, right? So task number 1 takes 30 minutes. So you can place task number 1 here, which takes 30 minutes. The maximum time is 57.6, so you can have, more tasks here. That is gonna make it still less than 57.6. Now you have 30 minutes. So going back to the time chart here, which task can we select that's still gonna make the total time to be less than 57.6? Anyone can guess? So we already selected number 1, right, which is 30 minutes. So the next candidates are task 2, task 3, or task 4. If you select task 2, then the time for task number 2 is 40 minutes. If you add this 40 minutes with 30 minutes here in the first task, it's gonna make it 70, which is beyond 57.6, so we cannot do that. So the only option that we can do here is task number 3, which is 26. So you're just gonna add, task number 3 here. So first you add number 1, and then you add number 3. That makes the entire the total time from 1 and 3 to be 56 minutes. And this is the maximum that we can add right now, because otherwise if we add more, it's going to be beyond 57.6. So we'll move on to the second station. So in the second station, your candidates to select, let's go back here again, are task number. So if you take a look at here, okay, if you see here, you know that you already select number 1, right? And you have already selected number 3. So the next task that you can select are either number 2 or number 4, right? You cannot select 5, 6, 7 because 2 and 4 hasn't been selected yet, or you can even not select 8, right? So your options are either 2 or 4. So let's go back again to the chart. So if you go back to the chart, you can see that here there's no right or wrong though. You can select either 2 or 4. So in this example, you know, I selected 2. So once you selected 2, you can select 5 because 5 is waiting for 2. If 2 is selected, then you can select 5. 5 only take 12 minutes. So 40 plus 12, that makes 52. It's still okay, you know, less than 57.6. But we still cannot add anything else to this second station. So we'll move on to the third station. So in the third station, your only option is task number 4, which has not yet been selected. So in here, task number 4 takes 54 minutes. You're not going to add anything else. And then we'll move to the next station, which is station number 4, and that's 28 and those are the tasks 6 and 7, making 52 minutes total, combining these 2 times. And the last one is task number 8 in session number 5, which takes 44 minutes. So this is how you just, you know, allocate a task into the workstation. And this is pretty much it for the live balancing technique. As mentioned earlier, you know, previously in station number 2, you can select the 2 first and 5, or you can even select 4 first. So here, if you select 4 first, it's going to be like that. Doing the live balancing technique in this lab, we use a technique that is heuristic. When I talk about heuristic, that means you don't have like one best solution. You have like way too many reasonable solutions that you can work on. So if you know you have 10 students here in this lab and you go and do the live balancing, you might not have the same picture for the Yamasumi chart, and that's okay because you know you have a lot of possible solutions as long as the solutions are okay. It's not like the optimal solution that you learned in OR that you're gonna get like the best solution, you know, among like the others. But this is not like that. It's heuristic technique. Okay, so once you have done allocating all the jobs, the last stage is to calculate how good you are in terms of, you know, doing the live balancing technique. And that measurement was done by what is called the live balancing ratio. And in this case, it's calculated by having the workload divided by the number of stations. In this case, you have 5 stations, so the number of stations is 5, and multiplied by the time of the station that takes the longest. So in this case, station number 1 takes the longest, which is 56 minutes. So we'll just put 56 minutes here as a time. And now your live balancing ratio in this example is 92.14%. The higher this ratio is, the best, the better your live balancing factory would be. So that means, you know, you have kind of like more balance of the times between like among all the stations. So we try to make it balanced. We are not going to try to have like one station having like the very long time, and that's not efficient in this lab. Okay, so this is pretty much it for the lecture. Now we're just gonna do the lab, but before we do the lab, is there any question from you guys before I move on? Let me just check names before I move on. Previously I was missing Shanina, right? And
ผมมาแล้วครับอาจารย์
And then the last one is Tanat sheet. Okay. Now you guys are all here, so let's just do the lab. To do the lab, as mentioned earlier, you know, this is the cars that you guys will be making. This left side is a sedan car or รถเก๋ง in Thai, and the right side is a racing car or รถแข่ง. Here, if you take a look at the lab sheet, I'm just gonna show the entire screen. Hang on. Okay. So, okay, this one. If you take a look at the lab sheet, I'm not gonna use that much of this one because we don't really do lab here. But if you take a look at on page 12 in table 10, you can see that I have already listed the task of making, you know, these two cars here in the lab sheet. So for example, 1L is for making the left front body, blah, blah, which I'm just going to show you the video later on. But so this is the task for the sedan car. If you move to the next table 11, these are the tasks for the racing car. So if you take a look at the simulation here. Okay, let me just make it quicker. Increasing the speed. Okay, so here if you add like the yellow block here with the stick here, I said like 6-hole stick because there are 6 holes in the stick. So if you add the block with the stick, the long stick and the short stick and the screw, doing this is one task, and this task is called 1L. So same thing here, you do 1L, and L means left on the left side, and then you also do task 1R, which is the same exact task, but it's just gonna be on the other side. So this is 1R. And if you add the green block, this is 2L. Green block on the other side is 2R. The blue block with the wheel, the back wheel, that's the 3L, task 3L. And then on the other side, this is 3R. Okay. And basically you just add things in every holes, right? So this is 4L and this is 4R. Okay. So 5L is the front wheel. So this is 5L. And the right side is the 5R. Okay, so here in the lab, I also added something that, okay, so your customer actually require you to finish all the hole first before you can add things on top. So P, who did the simulation for me, he made a mistake. Actually, this door here, I think this is called 8AL, which is like task number 8. For type A and on the left side. So this is 8AL and this is 8AR. 8AL and 8AR must be added first before we can add the top part. But here we add the top part first. So it's okay. So once you add 8AL and 8AR, you can add the top part. This is task number 6. The top part in yellow, this is task number 7A. And the last one is the spoiler on the back. That's number 9A. Okay. So this has to be done first, but it's done later, but it's okay. So once you have completed everything, so this is the sedan car. The last one, sorry, let me just pause a little bit. Hang on. If you take a look on the lab sheet in just a minute, sorry, where is it? Okay, this one. You also have task number 10 here. I said 10 and inspect. So basically you just, you know, hold the part up and try to like pretend that you are inspecting, looking, and then kind of like tighten up the screw. That's the task for inspection. So let's just move on to the next car. It's pretty much the same, by the way, but we'll just watch it anyway. So this is for the racing car. Starting off with the 1L. Remember, the two types of the product can have the same task too. If you since it's your own factory, it's the same factory. So this is 1L, 1R, 2L, 2R. These are the same. 3L and 3R. Okay. And 4L is also the same, same as 4R. And this 5 is the same. There are 4 tasks that are not the same, which I'm just gonna tell later on. Okay, so 5L and 5R. Okay, so here, same thing. You also need to add the front door before you can add the top part. The front door is like this shape right here because it's a racing car, so front door has to be more fancy, I hope. So you have to add this first, the left side and the right side, and these are 8BL and 8BR. And these two tasks are not the same, right? Remember, for the sedan car, you only add the screw and the lock. But here you also have like a shape of the door that's kind of like long here. So this is 8BL and 8BR. And once you add the door, then you can add the top part. Number 6 is the same. But 7 is not. So this is 7B. It's the task 7 for type B. Same for the spoiler. Spoiler is not the same as the previous one. So this is 9B. Okay. All right. So assume that you add everything in, then this is the finished, racing car. Okay. So once you understand like all the tasks, and what we did in the lab later is that we just gonna do, each task and then do them 3 times. So for 1L, we're just gonna do it 1L 3 times, 1R 3 times. Just do it like making the repetition to be 3. And 3 is actually not a good number though. But I'm just gonna still use it anyway because I'm just gonna stop it here first. Sorry. Stop.